The smart contract represents the core logic of a decentralized application. You must have noticed me using another term, smart contracts. Well, they are also an important part of any blockchain network. We will cover smart contracts in details later in the dedicated session on smart contracts. For now, back to dApps. The front end of a decentralized application represents what you see, and the back end represents the entire business logic. This business logic is represented by one or several smart contracts interacting with the underlying blockchain. The front end, as well as files like photo, a video, or audio, could be hosted on decentralized storage networks such as Swarm or IPFS. Traditional web applications use HTML, CSS, and JavaScript or similar technology to render a web page. These pages interact with a centralized database where all the data is stored. When you use a service like Twitter, Facebook, Amazon, or Airbnb, for example, the web page will call an API to process your personal data and other necessary information stored on their servers to display them on the page. User ID and passwords are used for identification and authentication with low levels of security, since personalized data is stored on the server of the service provider. In short, traditional websites are front-end to API to database. Decentralized applications are similar to a traditional web application. The front end uses the exact same technology to render the page. It contains a wallet that communicates with the blockchain. The wallet manages cryptographic keys and the blockchain addresses. Public key infrastructure is used for user identification and authentication. Instead of an API connecting to a database, a wallet software triggers activities of a smart contract, which in turn interacts with the blockchain. The front end should be Web3 compatible. In short, wallet to smart contract to a blockchain database. In contrast to Web2 applications, Web3 applications need a connection to the blockchain, which is managed by a special application called wallet. We already know the wallet keeps a record of private keys and blockchain addresses, which represents the unique identities and point of reference. Without a software that manages a digital identity, we will not be able to interact with the blockchain. The Web3 therefore builds on the current Web2 stack and introduces additional elements of an application level. In the backend, the Web3 adds a whole new infrastructure layer for decentralized applications to interact with the decentralized protocol stack. Decentralized apps need to have a component that manages a user's private key with which one can sign transactions on the state layer, the blockchain. When it comes to cryptocurrencies, dApps run on a blockchain network in a public, open source, decentralized environment, and by very nature of their implementation, they are free from control and interference by any single authority or organization. For example, a developer can create a Facebook-like dApp and put it on a blockchain where any user can publish messages. Once posted, no one, including the app creator, can delete the messages. Summarizing, dApps are decentralized. That makes them independent and no one controls them. They are deterministic. They perform the same function irrespective of the environment they are executed in. They are Turing complete, which means given the required resources, the dApps can perform any action. They are isolated, meaning they are executed in a virtual environment known as Ethereum virtual machine, so that if the smart contract happens to have a bug, it won't hamper the normal functioning of a blockchain network, in this case Ethereum. Following are few examples of dApps. Chainlink. Chainlink offers any smart contract secure access to data feeds, APIs, and payments. Brave. a web browser with almost 9 million active users. Brave is attempting to turn the online advertising model upside down by putting consumers in the driver's seat. The app creates a new measure of value in the advertising world where consumer attention is used to set value more than unverifiable views or clicks on a web page. EOS Dynasty. EOS Dynasty, which has nearly 12,000 unique daily users, claims to be the first role-playing player versus player game based on blockchain. MakerDAO, one of the well-known decentralized app, a decentralized credit service that runs on the Ethereum blockchain platform. It supports DAI, a stablecoin whose value is pegged to the US dollar. Chainyard. This dApp and consultancy is striving to solve problems with supplier information management systems, which today are slow, inefficient, and unable to adapt to new requirements quickly. Chainyard, a permission blockchain-based network, is designed to improve supplier validation, onboarding, and lifecycle information management. TraceDonate. TraceDonate provides a much-needed transparency and traceability to the charitable giving business. Its identity management platform is designed to allow for transparent and traceable cross-border remittances and giving. Circular. It is a dApp offering supply chain traceability, in this case for the electric vehicle and electronics industry. It provides traceability to demonstrate the ethical and sustainable sourcing of raw materials used in the production of the latter. Cipher. Cipher is a middleware that supports a portfolio of 4 blockchain dApps for government agencies and regulators in different regions. It includes a reconciliation and settlement network, tokenization of loyalty points, a procurement payment network, and a document exchange, verification, and compliance network for banks and their customers. KYC Chain. This app is used by businesses to verify customer identities and streamline the onboarding process in a way that meets Know Your Customer regulations. It can verify individuals as well as corporate and institutional business clients for criminal or prohibited activities in real time through a partner sanctions and watchlist database that spans more than 240 countries. DLT.SG. Built on the Hyperledger Fabric business platform, it includes a series of enterprise-grade blockchain dApp modules focused on supply chain and counterfeit recognition technologies. DLT.SG is built for collaborative e-commerce in large supply chain organization. It enables trade finance, tracks end-to-end product flow, and delivers a model for unlocking inventory and freeing up cash. The above are just few examples of popular ones. This list is really long, and many more dApps are being developed on a daily basis. It will not be wrong in making a statement that soon you will have a marketplace for dApps from where one will be able to pick up dApps rendering specific functionality for a very small cost to build larger applications or solutions. Now, let us look at some of the benefits of a dApp. They are fault tolerant. dApps don't have a single point of failure because no single node controls the data transaction or data records in this P2P decentralized network. Its distributed nature supports this very strongly. It prevents internet censorship. As there is no central controlling authority owning a dApps network, it controls and prevents the internet censorship violation. It is practically impossible to manipulate with data sets in an individual's favor. This means that not even government authorities can try to block a dApp because, being decentralized in nature, dApps don't depend on any particular IP address. Increased trust on the system. Again, because dApps are not owned by a single entity, users have more confidence and trust that their data will not be stolen or manipulated with.